So the final section of chapter 7 is to graph systems of inequalities. And as we were just talking about, we're talking about shading regions. So when we have more than one inequality on the same graph, we are looking for a point that is a solution for both. And we shade that region. It's often called the area that's overlapping, the overlapping area. So let's make a little box and we'll describe the steps for solving a system of linear inequalities. You really have to know a lot to graph inequalities, but the steps for writing how to solve a system can be written pretty succinctly, so you don't need a lot of lines, maybe 2 or 3 lines here. We'll come back and write the steps down after practicing one. So let's try solving this system of inequalities. We're no longer dealing with equations where you see equal signs. We're now dealing again with inequality signs. Okay, so we're going to graph each independently and look for the area of overlap. So when we look at the first one, it says y is less than, or it just says y is less than x minus 4. So right now, is it going to be solid or dashed?
The first one?
The first one.
Dash.
Good job. So the first thing you want to do is make a note of that. The most common error is to forget your dash lines. And now we can graph it just like it's a line, right? As though there was an equal sign there, but let's remember that it's an inequality. So it is in our favorite form, which is called what? Slope-intercept form. And the slope is? Anybody? The slope equals? You see it? It's the number in front of the x value. And so that coefficient there is 1. So 1 over 1. Good. And the y-intercept? Anyone is?
-4.
Good. -4. There's a negative in front of that 4. Okay, so we could go plot our y-intercept at -4. Starting point. And now use our slope to find the second point. Rise 1, run 1. And we could keep using our slope if we wanted. We really only need 2 points to draw the line. And then don't forget the line is, say it, dashed. So let's dash it. And it goes on infinitely, so put your arrows. Now, because it's an inequality, what must we do now?
Shade.
Shade. So we're going to have to do what to determine the shading?
Plug in a point.
Plug in a point. Test a point. Test. And so our favorite test point is?
0, 0.
Easy to put in. And is 0, 0 on the line we just drew? No. So it's a great test point. We're going to plug it right into the original. Here's the original. Now we'll plug in our point and test it. And since we're testing it, I'll put a little question mark. Is 0 less than 0 minus 4?
No.
I mean, really, 0 minus 4 is -4. So this is not true. The test point doesn't work. So we will shade away, so away from the test point. This way. So you may lightly shade with a pencil, or you could use these arrows showing where you would shade. But we're not ready to do the heavy shading until we have found the other shaded region, right? Okay, so the second equation, is this going to have a solid or dashed line? So this one we probably wouldn't ever make a mistake with. It's solid. And the slope, anyone, is? Good, -1 over 1. And the y-intercept is 3. Good. So we go plot 3. And we rise -1, run 1. And we said it's a solid line, so use your rulers, right? And it's an inequality, so we've got to shade. So what test point, Chad? What do you want to use?
Seven zero.
So he wants to test 7, 1, 2, 3, 4, 5, 6, 7, 0. That's an interesting test point. Okay. It's not on the line, right? Okay. So we're going to bring down the inequality and test when y is 0 and x is 7, is this true?
Yes.
So what is negative 7 plus 3?
-4.
Negative 4. Is 0 greater than or equal to negative 4?
Yes.
So the test point he has over here, an interesting test point, is true. And we're basing it on the blue line we just drew. So we're going to shade toward it. You see that?
Yeah.
All the way up the line. We would shade this way if there was just one blue inequality on there. So now we look at the two graphs and we find the area that both graphs have shaded. And just point with your hands, where is that? Where is that? Do you see it? It's this area here. Good. I see most of you pointing. So you put your heavy overlap shading there, and you now have the correct solution set. Okay? Questions so far? So we're going to write down how you solve a system. And really there's just two things. The first thing is anybody want to say what do? We graph the inequalities, right? Graph each linear inequality, dash or solid, and shading. Remember those things. Now there's a lot to that. You know a lot if you can do that, right? And then after you've graphed both, what do we do to show the solution? We graphed both, and what did we do? Jimena?
Test a point.
Well, no, that's part of the original graphing. We tested a point on both, we shaded both, and then to find the answer to this system, we... Sophia? Find where they're both shaded. Find the intersection of the half planes, the common shaded area, the overlapped area. You can call it whatever you like, right? In math terms, it's called the intersection of the half planes. Most people like to say it's where they're overlapping. Okay, so let's try, once again, solving this system of inequalities, which has 3 small inequalities in it. So go ahead and try for a bit, and then come back and check your work. And already you should be underway, right? The first one, Alana, is it going to have a dash or solid line?
Solid.
And what's the slope, Alana?
The slope is -1/1.
Good. And whoops, why did I write that? I was looking at the next thing I was about to ask. And that is, what is the y-intercept?
2.
Good. Okay, so we're going to plot our y-intercept at 2. And then we're going to go down 1/1. Down 1/1. And you said solid, so we draw a solid. Be sure you're using a ruler. It's hard to freehand it and have it look straight. And so, what do we have to do now, Alana?
We have to test.
Test a point, and what point would you like to test? Well, okay, good. 0, 0, she says, because it's not on the line. So here's the inequality, negative x plus 2. And when we plug in 0, what is negative 0 plus 2? It's just 2. So is 0 greater than or equal to 2? No, no, not a solution. Okay, so we're not going to shade toward 0, 0, we're going to shade away from it. Okay? Second inequality, y is less than 4. So Sophia Gambale, is that solid or dashed? So we must make a note of that. And then what is the slope? When you don't see an x value at all, what number wiped out your x? 0, right? The slope is 0, okay?
Yeah.
And the y-intercept would be what? It would be 4. Okay, so we're going to go plot 4, 1, 2, 3, 4. And it has a 0 slope, so show me with your arms what that looks like. 0 slope. Rise 0, you could actually put a 1 under there. And that's a true value, that's 0. So rise 0, run 1. Rise 0, run 1. We're just horizontal. Don't forget it's dashed. It is an inequality though, so Sophia, what do you want to test? Okay, she wants to test 0, 0 as well. So when we take this inequality and we plug in 0, is 0 less than 4? Is it? Yes. It's a solution, yes. So we will shade toward 0, 0. This way. Now I'm seeing, do you guys see this overlap? Over
Yes.
in this area, do you see the arrows are kind of coming together? So that's good. We have the beginning of the solution, but we do have the final inequality. So I'm going to go with green. And is this solid or dashed? Isabella?
Shoot.
Okay. And what is, this is weird. Do you know what this is?
Undefined.
Undefined. So what is it? Show me with your arms what that looks like. Up and down. So we actually don't have a y-intercept, do we? And we have this undefined slope. We simply walk to 3. X is 3 there. And where else is x3? You know, anywhere up and down here. So we have a vertical line. Okay. It's one of our special cases at x is 3. So, Isabella, we need to test a point though. What point? Okay, so that is not on the line, 0, 0. Is 0 less than 3?
Yes.
Yes. It's a solution. So we graph toward it, toward it, toward it, toward it. And we look for the region where all 3 graphs are shading. Do you see it?
Triangle.
Yes.
It's like.
There you go.